first part of chapter 2, we are going to look at radical functions. Alright? So, in this section, we're going to go back and add a special type of graphic. We're going to take everything that we were able to graph so far and say, now it is allowed that we can graph the square root of any graph we've ever seen. Yes. We are on page 83. Now you've done some square root graphing already. You've done your basic square root x graph and did all the transformations for that. Okay? But now we can square root x squared. We can square root a sine graph. We can square root anything and draw its graph. And it's going to go back to this important pattern that we noticed at the beginning. Sometimes when you square root something, the number gets smaller. Sometimes it stays the same, and sometimes it gets bigger. So this activity we did at the beginning is going to become super important for you thinking and understanding this unit. But here's our square root of x graph. We know that graph already. You could do all the transformations of that as possible. We could also graph the square root of x plus 4 using transformations. All you would have to do is move the square root of x plus 4, square root of x, 4 to the left. Yes? Yep. However, we're going to notice a new pattern. And this new pattern is going to be based on that idea at the beginning. The new pattern says if you could graph the inside, and the inside is just a straight line x plus 4. What did we know from the pattern that we saw? We know that if a number is bigger than 1, for example, on the red graph, you have 0, 4. If you square rooted that, that number would get smaller. And sure enough, on the blue graph, if you square root your y value, you get 0, 2. It gets smaller. The key points are going to be the ones that don't change. And what are the numbers that you square root that don't change? There's 0 and 1. Notice that on the red graph where it's 0, the blue graph it's 0. On the red graph, the inside graph where it was 1, the square root graph is 1. And then between 0 and 1, when you square root a number between 0 and 1, this has to be slightly above. Because square rooting a number between 0 and 1 always gives you a bigger answer. But never bigger than 1. Just a slightly bigger decimal. And so we can use this idea to graph the square root of x plus 4 as well. And this will be our new idea for graphing square roots because it works with any function inside that you can graph. And sometimes even ones that you have done before become easier with this technique. So if we go to example 1 here, and they give you the graph, and they say, can you sketch the graph of the square root? The first thing you're going to do is you're going to look for where are the values of f of x, where are your y values, 0 and 1. Because when you square root 0 and you square root 1, it's going to stay the same. Then you're going to check if there's any other nice numbers you could square root, like, oh, that's a nice number I could square root. What's the square root of 4? 2. And here's a nice number I could square root. What's the square root of 9? 3. So we're just square rooting our y values. And between 0 and 1, when you square root a decimal between 0 and 1, your answer has to be slightly above. Okay? There is some danger in this slightly above. This slightly above is good. Okay? Here's some slightly aboves that are bad. Slightly above that go back in time. That is very bad. They'll lose you half a mark every single time. You can't go back in time. Okay? square roots that are, right? Those ones are bad. Here's another one that's bad. If your slightly above goes over 1, that's too high. That'll also be considered bad. So it's got to be slightly above, but it can't go back in time. Don't over-exaggerate it. In fact, sometimes, even with the sharpest mechanical pencil, you almost have no room to do it whatsoever, and you will almost put it exactly on top of the line. That's the best that you can do. So we make that slightly above, and then going through the rest of the points, there's only an arrowhead on one side, because you can never square root a negative number. So whenever the original graph is negative, your square root graph won't exist, because we know we can't square root negative numbers. Next graph. Sure enough, it says state the domain of range. So my domain now is x is bigger than or equal to negative 2, because that's my smallest x value, and my range, y is bigger than or equal to 0. So when you're asked to square root a function, step 1 will be to draw the function. Lots of times on the exam, questions are like this. They already give you the picture. But it could be that inside you have to first graph sine of x, or you have to first graph x squared. So step 1, draw the original graph on the inside. That's done for us already. Step 2, find out whenever your y value is 0 and 1. Because if you square root 0, you get 0. And you square root 1, you get 1. Then I'd say, is there any other nice points you could square root? This one, no. If you extended this, you would hit 4 right there. So technically, when you square root 4, you would get 2 right there. But the idea is that when your y values are between 0 and 1, you square root a fraction like that, your graph has to be slightly above. And then below. So on the exam, what are they going to be looking for? For sure, they're going to be looking for, did you label these points where the y values are 0 and 1? Then, do you have your graph slightly above between the y values of 0 and 1? And do you have it below when the y values were bigger than 1? And for sure, you don't draw anything where the original graph was negative. Because if the original graph is negative, we can't square root. That's the big ideas of this unit. And so, here are some straight lines. And for the textbook, I'll give you the numbers for practice on this one. It's just number 5. The textbook likes to give you the graph first.